There are many database choices available for Python. For our purposes, we're going to be using SQLite 3 for a number of reasons. First of all, SQLite 3 comes with Python. If you have Python installed and you're watching this course, then you have SQLite 3, and that makes it easy for us for the purposes of teaching. SQLite 3 is a perfect choice for a lot of applications. For most of the website work that I do these days, I'm using SQLite 3 instead of MySQL, which I might have used a few years ago. It's reliable, it's simple, it doesn't require a separate database engine, it's self-contained, serverless, zero configuration, and fully transactional. It's a fully capable database engine in a driver, and that makes it just incredibly easy to use. And for our purposes, having something that's simple like this allows me to show you how databases work with Python without having to mess with the database a whole lot. We can spend our time in the Python. So we're going to go ahead and start by making a working copy of databases.py. Call it databasesworking.py. Go ahead and load that up. You see our first line here says import SQLite 3. And that simply imports the Python library that supports SQLite 3. And then here all we do is we say db equals SQLite3.connect and the name of the file, test.db, and we save this and run it, and we have created a database. We'll go ahead and refresh this file system here because Eclipse doesn't do that for us, and you see that we now have an empty file, but we've created our database. So we'll go ahead and populate the database, and that's also very simple. We simply say db.execute. And I'm going to give it some SQL here and say drop table if exists so that we create a new table each time and call the table test. And then db.execute, create table test, and give it a couple of fields. T1 is a text field and I1 is an int. And now I've created a table inside my database. Now I'll just insert a little bit of data. db.execute. Insert into test, T1, I1, values, question mark, and these are placeholders, and that allows us to give it a tuple with the values 1 and 1, and I'll just make a few of these. 2, give that a 2, and a 3 and a 4, and a 4 and a 3. And we have now inserted some data into our database. And so this is all done with SQL. And we say db.commit because SQLite is a transactional database. It will buffer these values in case you're going to be using it in a transactional mode. And then I say cursor equals db.execute and select star from test order by T1. Again, standard SQL for row in cursor. Print row. So now I've inserted some data into the database, and I'm going to print that data out from the database. Save it and run it, and there we have it. There's our 4 records, and they're sorted by the T1 field, which is our text field, and that's getting read from the database. So that's all there is to it. Using SQLite in Python is incredibly simple. Our first line here connects to the database, and that actually creates the file if the file didn't already exist. And then from there on, we're using db.execute because db is the database object that we got back from the connect statement. And we simply interact with the database using SQL. Be sure to do a commit after you change any data in the database. And then we can do a select and use the cursor object that's returned by db.execute and simply step through the cursor object as an iterator and print the data. The data comes back, you'll notice, in tuples. And they're in the order that you specify things in your SQL. So if I want it in the I1 first, followed by T1, I simply change my SQL so that it specifies an order, because the order it was in was the order that we define them in the create table, text, and then int. So if I want int and then text, I simply change it in my SQL, and it'll come back in that order. And obviously, if I want to order it by the integer instead of by the text, I simply change my SQL, and it comes ordered by the integer instead of by the text. There's one more thing I'd like to show you in this context, and that is the row factory that comes with SQLite. The SQLite interface is actually incredibly rich and very full-featured in Python, and there's a lot of options and a lot of methods that you can override and tremendous amount of power there for working with databases. We're going to keep it simple for our purposes here, but there is one thing that I want to show you, and it's what's called a row factory. Let's say db.rowFactory equals SQLite3.row. So what the row factory does is it allows you to specify how rows will be returned from the cursor. And the built-in row factory that's provided, SQLite3.row, is very powerful and very suitable for most purposes. So when I save this and run it, you'll notice the only change I made was to add that row factory there after the connect. You'll notice now we get row objects instead of those tuples. And the row objects can be looked at as tuples if we like, or it can be looked at as dictionaries, which I find particularly useful. So if I say dictionary like that, I'm creating a dictionary object based on a iterable, because row is an iterable. And so if I save this and run it, now I get dictionary objects. And so they're completely indexed. If I want to, I can say row sub T1, and I'll get my T1 objects. I can say row.T1, comma, row.I1, and get all the data. Save that and run it. The built-in row factory from SQLite is very flexible. I tend to use it in the dictionary mode because I find that very convenient, but it has a lot of other options, and they're all documented on the SQLite 3 page in the Python documentation. So as you can see, accessing a database from Python is very simple. Most databases have an interface very similar to this one. For most simple database applications, SQLite 3 is going to be a great choice, and you can see that it's very simple to use in Python.